Hello, everybody, and welcome back to some more of the 2001 Pascal paper. As always, I'm Root Beer, and I'm eager for another math question. So we're going to be taking a look at question number 24 here. A sealed bottle, which contains water, has been constructed by attaching a cylinder of radius 1 centimeter to a cylinder of radius 3 centimeters as shown in figure A. When the bottle is set upright, the height of the water inside is 20 centimeters, as shown in the cross-section of the bottle in figure B. So in figure B, we notice, just looking at the cross-section of the water here, that the water fills up the bottom tank and just a little bit goes into the smaller one. When the bottle is upside down, that's figure C, the height of the liquid is 28 centimeters. And we fill up the bottom one and we go a ways up into the bigger 3 centimeter radius cylinder. Okay. We're asked, what is the total height in centimeters of the bottle? Okay. So we have two cylinders here. It makes sense because we're talking about volume to break the volume of the whole container into two parts, the volume of the tiny cylinder and the volume of the big cylinder. Now we know the radii, and that's great because we start thinking about things like, okay, what's the volume of a cylinder? What's that formula? And it's pi r squared, where r is the radius, times height. And we don't know the heights. We don't know the height of the small cylinder, we don't know the height of the big cylinder, and we don't know the height of them combined, which is specifically what we're being asked, total height in centimeters. So it might be a good idea for us to give names to the things that we don't know. We know the small cylinder's radius, we know the big cylinder's radius, but we don't know the small cylinder's height, and we don't know the big cylinder's height. So I'm going to call that little h and big H. Okay, so let's go to the notepad and see what we can work out here. So we're going to let H be the small cylinder height and capital H be the big cylinder height. Okay, and in total, the total height, which is what we want, is H plus H. Okay, little h plus big H. So in a perfect world, I think we would figure out little h and then capital H, and then we would add them together, although it's possible, because we only have a couple figures here, it's possible we might not be able to figure out what little h and capital H are right away. We might, on the way to figuring them out, actually figure out what little h plus capital H is, in which case then we can stop. We should always be mindful of what we're actually being asked to solve for. We don't actually care what little h is. We don't care what big H is. If we had them, we could get the total height. So we should be looking out for them. But if at any point we figure out what little h plus capital H is, we can stop. We're done. We don't actually need to work out what little h is to get the answer here. But because we've written our total height formula as little h plus big H, it makes sense to break the problem down into, let's find little h, let's find capital H. And this gives us a direction we can go for the question. Okay, so let's redraw our pictures here. I'm not going to redraw figure A, but I will draw figure B. So we have our little cylinder and our big cylinder. So this is H, and then we have height of 20 here. And we have a height of little h here. And the water for figure B goes up only a little bit. So this distance in here is actually going to be, well, it's going to be what's left over after we take out the height of h. So it's going to be 20 minus capital H. Okay? So the volume of the water, in this case, well, we have two cylinders here. One of height capital H, one of this very tiny height of 20 minus capital H. So the volume of the water is going to be, what did we say? So pi r squared. So the big one here has radius of 3 centimeters. The small one here has a radius of 1 centimeter. So 3 centimeters squared times the height, and then pi 1 centimeter squared times the other height. So now we'll have a volume, and we can expand this out. We'll have a volume just in terms of capital H. So I get 9 pi h plus 20 pi minus pi h. So I can take out a pi here, because I think a lot of my formulas are going to have pi, and I'll get 9h minus h, so that's just 8h plus 20. Okay. But if I look at figure C, where the jug of water is being held upside down, then I get that the water fills up a fair bit of the big one, but it fills up all of the small one. And the small one has radius h. We have capital H up here for the total height there. And we're told, I think it was 28, but let's just double check. Yeah, 28 centimeters. So what's left over here, the height of what's filled up in the big cylinder, is going to be 28 minus the little h that is already taken up. And it's the same water, so we'll still get the volume of the water, but now we are pi 1 squared little h, for the volume of this small cylinder, plus pi 3 centimeters squared, 28 minus little h. So we can expand those out. Pi little h plus 9 pi 28 minus h. And taking out a pi again, we will get h and the 9 minus little h. So we'll get negative 8h. And we'll have 9 times 28. Well, fortunately, calculators are allowed on this contest, so I can really quickly get 252. Now, it's the same amount of water, so both of these equations for the volume of water are going to be the same. So pi 8h plus 20 is equal to pi 252 minus 8h, little h. Okay, so we just get a single equation, 2 unknowns. I don't think we're going to be able to work out little h and capital H right away. So I think what will happen is we'll actually get h plus big H. So I can divide both sides by pi. Like I said, we're going to have a lot of pi's in our equations. And we'll have 8h plus 20 is 252 minus 8 little h. I can bring the 8 little h over to the other side. I'll get 8 capital H plus 8 little h. And we'll bring the 20 over to the other side, 252 minus 20. That's 232. So I can take out a factor of 8 here. So 8 times the total height is going to be 232. So if I want the total height, capital H plus little h, we'll just rewrite this equation here. If I want h plus h, I divide both sides by 8. And 232 divided by 8 is 29. All right. So we have the answer we want. The total height is 29. And we'll go back and we'll figure out which of those answers corresponds to 29. A 29. All right, and if I know that 29, can I just mentally work out? Can I figure out what the little h and capital H are? I don't know. Well, that means I got 1 centimeter left here. So I can figure out, yeah, I can figure it out. So with this 28 height in figure C, I know I've got 1 centimeter left, so that's 1 centimeter times 3 centimeters squared times pi. So we have 9 pi volume left. And, will that, yeah, that'll, I don't know. Questions for later. If you were able to figure out little h and capital H, or even if you were able to do this question some other way, by all means leave a comment. I'm not going to go through and try and work out what little h and capital H are, because as I've already said, it's immaterial to actually answering the question, and I don't want to waste anyone's time. So that does it for this question, which was question number 24. So we got one question left to go, and that is question number 25, and that will wrap up the 2001 Pascal paper. So as always, thank you guys so much for watching. And join me in the next video as we wrap up the contest.